So in all of our previous examples, we had a natural log equal to a natural log. In this case, we have a natural log equal to a number. So we cannot use the one-to-one property. Instead, we have to go back to the definition of a log and rewrite this thing. Again, in order to get this x by itself, that's our goal, we need to get it out of the logarithm. So in order to do this, we can rewrite that natural log as an exponential. If e is the base of the log, then e is the base of the exponential. That 2 becomes an exponent, and on the other side, 8x is our output. Again, this is just our rewriting properties. The inside of the natural log is outside of the exponential. The outside of the natural log is the inside of the exponential. Now, 8 is not by itself yet. In order to get it there, we need to divide both sides by 8. So to get this into our calculator, again, we have an e squared divided by 8. To get this into your calculator, as a reminder, alpha F1 brings up your fraction menu. Hitting enter will give you a nice template for your fraction. We want an e squared in the numerator. So second, your blue key. E is located behind the natural log button there. It says e to the x. It even gives you a box to put that exponent. So we have an e squared on top. We have an 8 on the bottom. And again, we're going to have quite a few answers that look like this. The whole number answers are gone. So we get, we'll round to the nearest 10,000th like we did in the last example, 0.9236. Just like before, it is important to go back and check for extraneous solutions. If I wanted to do that, remember my original equation was natural log of 8 times x. I can actually scroll up here and get a slightly more accurate one, except I did forget my multiplication symbol. There we go. And when I hit enter, I should get a number that's really close to 2. In fact, I got exactly 2. That was quite nice. Thank you, calculator. Again, when you go to substitute, if you're using the rounded value, 0.9236, you'll get a number that's a little off, but 1.9999 is pretty darn close to 2. So we do have what we want here. That solution does work. Looking at one more of these where a log equals a number, note that I do need properties here. Subtraction on the outside becomes division on the inside. So I will have an x divided by 9 on the inside of that natural log. Once again, I cannot use the one-to-one property here because I don't have log equal a log. I have log equals a number. So I'll have to rewrite this using e as my base. Once again, the input and the output switch. So I'll have e to the 7th equals x over 9. X still isn't by itself here. In order to fix that, I can multiply both sides by 9. So x is going to be 9 times e to the 7th. Again, we'll need our calculator for this because that is not a nice number. So we wanted 9 times e to the 7th. We wind up with that really large number, 9,869. So let's go ahead and write that. Man, that's a big old number. And then to double check our work here, well, I'm supposed to have natural log of that value, 9896.6984, minus natural log of 9. I should get something really close to 7. Note I got 6.999999999 for quite a while there, so that is going to be a good solution. So here we looked at a couple of cases where logs equal to number. We also had some examples where log equal to log, and we got those nice one-to-one property problems. So try some of those logarithmic examples. In a second, we're going to start looking at exponential ones. So raise your hand if you have a question. Let me know if you need anything. Otherwise, stay tuned. One last round of equations to go.